Let me begin with three simple questions. What is cheapest RFID tag? Why cheapest RFID tag? And how the cheapest RFID tag works. There are two types of cheapest RFID. Cheapest RFID consists of active or passive, where cheapest RFID consists of fully passive since there are no circuit built-in. Radio frequency identification (RFID) is well-known wireless technology that has emerged for capturing data from stationary or dynamic objects. RFID uses electromagnetic field to automatically identify and track tags attached to objects. RFID technology is intended to replace barcode because of its low capacity for data and is complicated for reprogram the information. Due to the passivity of the cheapest RFID tag, this technology opens door for low-cost cheapest RFID application. Cheapest RFID tag can be fabricated on any substrate such as thin paper material to hard metal, which is challenging to accomplish with chipped RFID tag. How the cheapest RFID tag works? The cheapest RFID tag works on the principle of backscattered base tag, which the cheapest RFID tag uses radio wave to activate the chip and uses the radio wave to contain the information and retransmit it to the receiver. The problem the cheapest RFID tags now have is the critical requirement for the cheapest RFID tags are compact size and high density of data. Further optimizing the cheapest RFID tag design, the number of bits can be increased. In addition, the efficiency of the bandwidth can be significantly improve the performance of cheapest RFID tag. The limitation of the number of bits is critical in tracking identification application, where the cheapest RFID tag competes with the barcode technology in commercial project labeling. The objective is to design and develop 20 resonant operates between 2 to 10 GHz frequency range for the 20-bit cheapest RFID tag and to validate the performance of 20-bit cheapest RFID tag prototype in identification and tracking application. The scope of this project is for workers at factory. The workers will have cheapest RFID tag integrated into the ID badge, where we will assign different bits for each worker. The ID badge also can identify whenever the worker enter or exit the factory. Besides that, the cheapest RFID tag also can track the location of the worker. The significance of this project is each resonant have different parameters to encode data at operating from 2 to 10 GHz frequency range. The number of resonant elements is increased to operate 20 bits of information. The expected prototype of the design may be applied for identification and tracking purposes. Designing a cheapest RFID tag starts with determining the desired material. Proper material will enhance the performance of cheapest RFID tag. Next, the parameter of the dimension of the design and the resonant layout pattern need to be done. After that, do a simulation in CSC software. Perform full wave analysis. Next, examine the S parameter result whenever the frequency response is acceptable or not. The material used for the conductor is copper foil and copper. The difference between those two is the thickness and the flexibility that copper foil has. Next is for substrate. There's 4 materials used, which is PEP to represent plastic, FR4 to represent thick metal, denim to represent thick cloth, and polyester fiber to represent high quality cloth. The fabrication of FR4 based cheapest RFID tag is done by using CNC machine. First, export the design in DXF format, then import the design in ArtCamp to select which surface to engrave. Then use the generated G-code file at CNC software to begin fabrication process. Dimension analysis analyzes the performance of cheapest RFID tag in different shapes. Will be analyzed in 5 different shapes such as circular, triangular, quadrilateral, octagon, and octagon. The measurement probe will be used is radar cross-section probe. As you can see from the result of the dimension analysis, only octagon slot resonant able to achieve 20 bit at the given frequency range, whereby the other shape like circular, quadrilateral, and octagon can achieve 20 bit but need tune to this design. Lastly, the triangular can't be used as a shape for the cheapest RFID tag due to the distorted signal. This shows that the cheapest RFID tag design can change the ID of the tag by removing few slots. Next, the material analysis of the cheapest RFID tag is to validate the performance of cheapest RFID tag using different substrate. We validate in 4 different substrate, which is PEP, polyester fiber, FR4, and denim. The measurement probe will use is radar cross section and S parameter. PET and polysilicon fiber-based cheaper survey tag design is able to obtain 20 bits at the given frequency range. Next, the IDs of the PET and polysilicon fiber-based tag can be changed as shown. Even changing the IDs, the performance of cheaper survey tag still maintain 20 bits of information. Next, the FR4 and denim-based cheaper survey tag design able to obtain 20 bits but quite unstable at the given frequency range. Even the unstable state of the resonant frequency still maintains 20 bits of information while changing the IDs of the tag. Next, in S parameter, we will mainly focus S11, which is return loss. As shown in the result for PET and polysilicon fiber based tag, able to obtain 20 bits below negative 10 dB. Next, the IDs of the PET and polysilicon fiber based tag can be changed as shown. Even changing the IDs, the performance of cheaper service tag still maintain 20 bits of information and below negative 10 dB. Where the FR4 and denim based cheaper safari tag design able to obtain 20 bits but destroyed after the frequency of 3.5 GHz. This is because the gap between the resonant is too wide, which collapses with the nearby frequencies. In distant link from the receiver analysis is to determine the performance of cheaper survey tag information can be received by the receiver at a given distance. Only the PET and polysilicon fiber based tag able to maintain 20 bits of information at the given frequency of 100 meter, 150 meter, 200 meter and 300 meter. What we conclude is the fundamental aim of this project is to design and to develop cheaper survey tag that contain 20 bits of information. With the implementation of this design, the suitable dimensional and material for the cheaper survey is to achieve good result in terms of radar cross-section and S parameter is achieved. The only drawback of this project is fabricating the measured result. The design is small in size and high density of data compared to the previous work. Only FR4 based material design can be fabricated by using a CNC machine. Time constraint and the limitation in terms of ability of fabrication has caused the project to be concluded.